Good morning for those of us joining in the United States, and good afternoon or good evening for those of you joining from Europe and Asia. My name is Sarah Blanford. I'm the Deputy Program Director at the U.S. Energy Association under our Energy Utility Partnership Program, which is a USAID funded program. I imagine many of us on this webinar today are joining because at some point we got to know Padu professionally or personally, and jumped at the opportunity to hear from him on the important topic of India's energy efficiency journey, and highlighting Padu's book, which I have sitting next to me. Of course, I want to show it off, India's Energy Efficiency Journey and a Radical Vision for Sustainability, First Fuel. I'm proud to say I've finished it from cover to cover. I'm one of those people that was inspired to do this webinar because of my history with Padu. For me, I got to know Padu a few years after I started working on the U.S. Agency for International Development's South Asia Regional for Energy program. So this would be 10, 15 years ago. At the time, we were focusing our attention on providing capacity building to the region and doing a lot more work on energy efficiency and renewable energy. And Padu had amazing insight and experience and intuition, quite frankly, in this field. So I quickly started to consider Padu almost a mentor. I don't know if he knows that or not, but that's how I viewed him. And so you can imagine how delighted I am to have the opportunity to interview him today about his first book, and to showcase the amazing progress that India has made on energy efficiency. So we're really pleased to have him today. So Padu Srinivasan Padmanabhan was the former program director of the South Asia Regional Initiative for Energy program that I mentioned to you early, and senior energy advisor for USAID, India's bilateral program. He has served with the World Bank in Washington, D.C. as an energy efficiency specialist, and was a visiting fellow with the King Abdullah Petroleum Studies and Research Center in Riyadh, Saudi Arabia. He has over 4 decades of experience in the design of natural and regional energy efficiency programs, power sector reforms, regional energy integration, energy water nexus, clean energy and energy access projects, including the planning and establishment of national and regional centers of excellence in energy efficiency. He is a trustee of Altech Foundation, a Bangalore-based NGO devoted to advancing water energy sustainability, and is the founding member of the Alliance for Energy Efficient Economy in India. Padu is the recipient of several international and national awards in energy management and efficiency. These include the Regional Energy Manager of the Year 2019 by the United States Association of Energy Engineers, and the World Clean Energy Award 2007 by the Swiss-based Transatlantic 21 in global recognition of his achievements in advancing energy efficiency and renewable energy. He is the recipient of the Hall of Fame Award by the Indian Green Building Council in 2013, the All India Power Award in 2010, and the Energy Professional Development Award 2008, given by the Association of Energy Engineers India. Ooh, that was a lot of awards. Padu taught at the School of Advanced International Studies, known as SAIS, at Johns Hopkins. He has a BE in Mechanical Engineering from the University of Madras, postgraduate certificate in fuel efficiency from the National Productivity Council of India, and diplomas in energy management from UCTI Institute for Industrial Reconstruction in Rome and the International Labour Organization, Turin, Italy. Padu is here today to talk to us about his pioneering book that recounts the evolution of energy conservation and management in India since the early 70s. The volume provides approaches to mainstream energy efficiency and captures the benefits of the clean energy solutions in the country to mitigate greenhouse gas emissions and address climate change. So, with no further ado, we will launch into some questions for Padu. And we will be keeping 5 to 10 minutes at the end for anybody who wants to post their questions into the chat box. We will take those at the end. So Padu, are you ready?
Sure, go ahead.
All right. So let's start with a title. How did you come up with First Fuel as the title?
Before that, thanks for the warm introduction, Sarah, and thank you, USEA, for the opportunity to discuss about my book. Good evening and good afternoon, and good evening, good afternoon, and good night, really, wherever you are on the globe. On the book's title, I've often been asked this question: how did I come up with the title First Fuel? And actually, I was intrigued by an observation made by a former president of India, Dr. Abdul Kalam, the late Dr. Abdul Kalam, who mentioned once that energy efficiency is the sixth fuel after coal, oil, gas, nuclear, and renewables. And some of us got to do some number crunching, and we determined that indeed, it's not the sixth fuel, it's actually the first fuel. And around that time, I think it was in 2003 or 4 or thereabouts, the International Energy Agency in Paris had done its own calculations, done its own reviews, and found that in 11 of the 17 countries that they were engaged in, energy efficiency saved more fuel than oil, coal, or electricity. And indeed, energy efficiency is the first fuel. So the idea of energy efficiency becoming the first fuel was rooted in my mind as well as that of the contemporaries. So when I decided to write this book, I thought I should title it as The First Fuel.
Thank you. So this book, when I was reading it, almost reads like a history book at times. And you shared a variety of interesting little stories with a number of key players, some behind the scene kind of folks and others that took more center stage roles. Looking back at those moments, can you think of any that stood a good chance of turning out differently than what they did, either with a better ending, kind of a missed opportunity, improving India's path towards energy efficiency, or an opportunity that was missed and India's progress experienced a setback?
Yes, you're right. It's a story. And in India's energy efficiency journey, there were several forks in the road. And some of these forks in the road, whether we took the right road or we did not, is the question. Sometimes we did, sometimes we missed the road and went off at a tangent. But the point here is that there were a couple of occasions when we could have done a little better. For instance, in 73, after the first oil shock, and I've described that in some detail in my book, the focus in India was petroleum conservation, and that too fuel oil conservation in industry. Perhaps in retrospect, 2020 hindsight, we could have focused on other sources of energy, coal and electricity, rather than focusing only on fuel oil. And also we could have expanded our scope to include other sectors, such as the agricultural sector, the small industrial sector, because we were focused largely on the large sector, the power sector, and so on. So that was one opportunity I thought we kind of missed. The second was in 82, 83, when the government of India did a study with the help of the National Periodic Council on energy conservation opportunities and policies in the industrial and other sectors. They had recommended in very strong terms, in very stark terms, that the country should have an Energy Conservation Act, and there has to be an agency to implement the act. Somehow that recommendation was not followed through. It took almost 20 years in 2002 for the Indian Parliament to form or to pass the Energy Conservation Act and establish the Bureau of Energy Efficiency to implement the act. So I thought that was another opportunity that was missed. A pet peeve of mine has been that India has focused, and perhaps there was a reason to do so, on what I would call as energy audits in the industrial sector, and has brought it to a very fine art. And today, energy audits is now fairly sophisticated. But an energy audit in and by itself does not save you energy. It just helps you prioritize where the energy efficiency measures are. It's like a way station. It's not a destination. And as you know, energy efficiency cannot be metered. It has to be computed. You need a before and an after. And I sometimes wish that we had, along with our energy audit function, also developed the science of measurement and verification, because an M&V system will actually help you to move into saving energy. And that probably did not happen, although now, maybe 20, 25 years later, there's a lot more focus on measurement and verification. So that has always been something that has left me a little disturbed, that we should have advanced the measurement and verification function of energy efficiency.
Thank you. It's really quite enlightening. I'm glad you were able to share some of those moments. Along that same vein, like any industry trying to make improvements, it can be assumed that India started its energy efficiency journey with the low-hanging fruit. The easy stuff they can make, the relatively easy stuff that can make an inexpensive change and result in the biggest savings. Did you find this to be the case with energy efficiency? And if so, what are going to be the next challenges that the industry or India specifically will be facing?
Well, there are two challenges which Indian industry would have to face. One is a technical challenge, and another is a strategic management challenge. And let me explain. As you very rightly said, energy efficiency begins with the low-hanging fruits. And in fact, one can look at energy efficiency as 4 quadrants. The first quadrant is housekeeping or first stage measures, which are the low-hanging fruits, the no-cost, low-cost measures. And Indian industry has done rather well in implementing most of the low-hanging fruits. The second quadrant is what I call as must-dos, and this requires some investment. Return on investment is generally very good, and it involves measures like combustion control, improved boiler operation, furnace operation, steam insulation, efficient electric motors, waste heat recovery and management, and so on and so forth. And most Indian industries, definitely the large industries, have incorporated many of the must-dos. The third quadrant is integrative energy design, and I'll come to it in a moment. And the fourth quadrant is transformative technologies, that is nanotechnology, circular economy, digital technology, and so on. And here there has been some progress, but it's still far out in the future. So on the third quadrant of integrated energy technologies, Indian industry is knocking on the doors of the third quadrant. And what is integrative energy technologies? That's the challenge. It's basically, very simply said, an energy efficiency measure has both downstream and upstream impacts. And what that really means is that you need to kind of look at a measure and see whether you not only get energy savings, but you also get capex savings. Now, for instance, if one were to look at insulating a pipe, insulating steam pipes, one would save a lot of heat. One would save, in turn, a lot of steam. And that, in turn, would mean that your boiler can be downsized and your pumping systems can be downsized. So you not only have operational savings of energy, but you also capex savings in terms of the smaller size of installed capacities. Lighting is another good example. We all now know about LEDs, and many industries are moving from incandescents to LEDs. An incandescent lamp has a efficacy of, let's say, 20 or 30 lumens per watt. An LED has about 150 lumens per watt. You get 75% savings in energy. But actually, what energy you actually save would be less if your application efficacy is low. In other words, if the area that you want to get lit up is not receiving the light, not receiving the lumens. So you need to look at overall system efficacy rather than just looking at lamp efficacy. And lamp efficacy is one part of it. You have another part is the fixture efficacy, and the third is the application efficacy, and the total is the system efficacy. And that's what you need to look at to improve system efficacy. There are many, many examples. I just explained some simple examples. There are many examples where one could look at opportunities to improve efficiency by 20 to 30% higher than what you're already achieving. So this is a technical challenge. The second challenge is, as I said, the management challenge, or the most strategic challenge. And this challenge is really moving energy efficiency from the boiler room to the boardroom. What's happening is that we have been asking this question for which we have the answer, or at least we are searching for those answers. How is energy used? And the answer is pretty straightforward. You do an energy audit, you identify the efficiency measures, you prioritize them, you implement them, and that's end of story. But now we need to move into asking this question, what is the energy used for? The moment you ask this question, what the energy is used for, you begin to see the value that energy brings to an enterprise. Do you manufacture, for instance, steel ingots, or do you go all the way and manufacture precision tools? If you were to manufacture precision tools, you're creating a higher value, and energy generated and the energy delivered per unit of the higher value added item is much greater than just manufacturing steel ingots. Similarly, for aluminum, do you manufacture aluminum ingots, or do you go all the way and manufacture airline fuselages? In the case of paper, do you manufacture ordinary paper, or do you manufacture specialized paper? So there are many, many examples. It's not as though industry is not doing it. Industry can do more. And corporate India needs to move energy efficiency from the boiler room to the boardroom, because these kinds of decisions of value addition is a decision that is taken at a much higher level. And that's why I say that's the strategic management challenge of trying to add value to the energy that you consume.
Thank you. On the corporate, as a follow-up, on the corporate level, do you feel that what's holding them back from taking those next steps that you talk about? Is it just lack of knowledge in the subject area, or are they not convinced of the financial incentives?
Well, there is a certain lack of knowledge, but it's also to do with modernization and diversification. And these decisions cannot be taken overnight. They are part of a strategic long-term decision making. Because if you want to move from one line of product to another line of product which adds more value, you have to look at what the market requires and so on and so forth. And these two do determine the energy productivity. What I'm talking about is energy productivity as against energy efficiency. What I'm talking about really is we're reimagining energy efficiency and looking at it from the lens of energy productivity. And energy productivity is something that corporate India is striving for. There have been definite gains made, but a lot more needs to be done.
Thanks, Padu. You have I think it's almost a chapter about cogeneration in your book, so I'd like to talk about that. Cogeneration helps overcome the main drawback of conventional electrical and thermal systems, the significant heat losses that detract greatly from efficiency. In the book, you tell what for me was an enlightening story in this book about the sugar industry's use of cogeneration. Can you tell us a bit more about that story, the amazing transformation that it made that cogen made in the industry?
Yes, you're right. As a concept, cogeneration is as old as the hills. It's using a single source of energy to meet heat and power demands of an enterprise and doing it in a very efficient way. The conversion efficiencies are higher. And it was, I think, in the late 70s during the administration of President Carter that cogeneration got a fillip due to the PURPA Act, the Public Utilities Regulatory Policy Act, wherein utilities were mandated to buy cogenerated power from a qualifying facility at their avoided costs. It was fascinating for some of us in India when we heard about it, that maybe perhaps that concept, a PURPA kind of an arrangement, could actually be thought of in the Indian context. And when we looked at Indian industry at that time, and I'm talking about the late 70s, early 80s, we found that the sugar industry had been cogenerating for a long time. It's part of the process, but they were cogenerating within the fence, not really selling any part to the utility. And at that point in time, India had, apart from the need for efficiency, there was also a need for augmentation of power, because there was a big gap between demand and supply just was not meeting the demand, and there were power cuts and shortages and so on. So we thought maybe cogeneration not only can deliver efficiency, but also can deliver augmented power. And sugar industry is in rural areas, so sugar industry can provide power to rural areas which normally did not get reliable supply of power. But it was a couple of years later, when I was in Washington, D.C., when I met with the Hawaiian sugar industry folks. And we put together a program where we had a partnership between the Hawaiian sugar industry, which had been cogenerating very, very efficiently for a long time, and the Indian sugar industry and an Indian sugar equipment manufacturer to do a project development study in a state in South India with power sales to the utility, to the Tamil Nadu Electricity Board in this case. And that particular study had to kind of go through a little bit of a revision. It didn't follow the Hawaiian practice of selling part to the grid, but it was selling part to a third party, what we call as wheeling and banking. Anyway, there are a lot of innovations which were considered in that project, including the optimization of boiler efficiencies. The boilers were much larger and much higher pressures than what were traditionally used in Indian industry. The turbines were much more efficient and so on and so forth. But at the end of the day, this particular sugar plant could generate 20 megawatts of power, consume 5 megawatts itself for its own requirements, and sell 50 megawatts to the grid. And within, I think, 2 years after the study, the management of this company actually set up this cogen plant, entered into a power purchase agreement with the Tamil Nadu Electricity Board, and began to wheel power and bank power with them and sell their power to a third party. Now, this concept was for the first time in India. At that time, cogeneration in India was about few hundred megawatts in the sugar industry. And today it's about 10,000 megawatts. And this particular project got replicated in a neighboring state, and then it became pan-India. And there were a lot of improvements made. The government of India got involved in it, the Ministry of Renewable Energy, and cogeneration, took a firm place in the Indian context, and it spread to other sectors of industry. But it all began with this project in Tamil Nadu with the sugar industry.
I love it. Okay, well, that's a good segue then. So this Hawaii-Tamil Nadu partnership, one of many, many, many that I'm sure you could recount from your times, this this bilateral friendship and cooperation. What do you think, and that was a great success story, what do you think are some of the essential features or characteristics of a successful US-India partnership in advancing clean energy and energy efficiency in India? What do we need?
Actually, you need three things, if I might say so. One should be mutuality of interest, what I would call as strategic self-interest from both countries. The second would be skin in the game. And here the beneficiary needs to have more of a skin in the game than the donor. And that would mean leveraging the donor's resources many times over. And we have had examples of that. And the third component, I would say, is the role of institutions, but more than institutions, individuals, people who take leadership on both sides, who are driven and who want to make things happen. Now, when you talk about, these are some of the prerequisites for a successful program. But when you talk about a partnership between the world's most advanced developed country like the US and an advanced developing country like India, then you need to look at other areas where one could actually make a difference. And to my mind, innovation is extremely important. Innovative ideas. It's not the resource you bring to the table, but the power of the idea. Are you the drop that makes a difference? That's what counts. And for this, the donor should be in a position to take some risks. The government of India cannot take any risks because it cannot afford to fail, but the donor can fail. That's important to know. Also, the donor does not have the resources, and nobody really has the resources to do something at scale. So it has to be done at a pilot level, taking a number of risks and ensuring that this project meets some of the design outputs that you look for. And that's where the risk element comes in. So just to sum up, you need the three basic pillars of, successful partnership, mutuality of interest, and the whole issue of leveraging, and as also the issue of leadership. But you also need the donor to take some risks and design and develop an innovative project. And we have had examples. The green building movement is a very good example of that. When we first started with the program with the US Green Building Council, we had just one project, the first platinum awarded project outside the United States in Hyderabad, India, 20,000 square feet project. But that project, in turn, actually led the green building movement. And today, India is number 2 in the world with 8.5 billion square feet, all in a matter of 15 years, where we took the risk along with partners, very strong partners who had more than the ordinary skin in the game, who put in the resources. And what we did was really create the ecosystem for both entities, the Indian Green Building Movement and the US Green Building Movement, to come together. And that led to one of the world's largest green building movements one can think of.
Those are a lot of lessons. I think many of us on this call today work in this field full time, and I think that's lessons we could apply to all of our work across the world. Identifying those champions and getting people that are willing to go that extra mile. I personally love the story you shared in the book about your visit to a North India state. I went back and double checked, and I don't think you gave the name, which was subtle of you. You were part of a World Bank team, and you were doing some work on a demand side management program. Can you share this story with the participants that haven't gotten a chance to read the book yet?
Well, there are many anecdotes in the book. At last count, I think there were 30 or 40 anecdotes, and this was just one of them. But certainly it was an interesting one, and it's somewhere in the middle of the book. So you have plowed through half of the book for sure, Sarah, when you read this. Yes, I do recall this. This was in the year 95, 96, so it's more than 20, 25 years back. And I was accompanying a team, an international team, to visit the state. And we were really looking at power supply to rural areas in the state, and the quality of power, and the reliability of power, and the efficiencies which power would be used, and things of that kind. And when we reached that state, or the state capital, we actually realized that the state was in the midst of electioneering. There was a state elections due, and the politicians were, actually making a whole lot of statements in the press and so on. And there were huge advertisements by the ruling party that they have actually reached power to every corner of the state. There's power available 24/7 in rural areas and so on and so forth. And the opposition was saying exactly the opposite and saying that, there are huge power cuts, etc. Anyway, we did not pay much attention to it. But when we went to these rural areas, and on our return from one of the rural districts back to the state capital, it was dusk and it was late in the evening. And we were passing through small towns and villages and so on. And we could see that there was a lot of light. I mean, the villages were lit up. I wouldn't say lit up, but hamlets had light. Street lights were on, and the towns were definitely lit up. So we just looked at one another and said, hey, maybe what the government is saying is absolutely true. There is power. Until one of us just looked back and found that as we were progressing, there was a receding darkness at the back. In other words, the power which was being supplied was being cut off systematically in tune with the advancement on the road. So when we passed a village which was lit up, the same village had its feeder cut off. And then we realized that the utility management actually had been told to do that so that they can create a good impression among the visitors. But I must say, 20 years later, and this is important, the state really now has 24/7 power to all the rural areas. But it was an eye-opener that, things like this could happen. So I just related that anecdote.
I keep picturing somebody from, one of the system operators sitting there at his, at his panel with a GPS tracker, see where your car is, so you can flip the switch, so to speak, on different towns. Oh, well, it's good to hear. It's good to hear that they've progressed. We talk a lot about energy efficiency measures that can be taken up on the demand side. The industry, particularly in India, has made huge strides. We've made that more than clear to us in reducing technical losses, which is a direct example of energy efficiency. What efficiency gains can be made, you feel, from the supply side, particularly the generation, transmission sides, and what motivation do those parts of the sector have to make these changes, which I think it's safe to assume are oftentimes extremely expensive changes?
Well, you're right. Supply side efficiency is extremely important. And we had a bilateral project which became pan-India and very popular, known as the DRUM program, Distribution Reforms, Upgrades and Management. And the purpose of DRUM was to create centers of excellence where one could test, demonstrate, and validate efficiency improvements in networks, in distribution networks, both urban as well as rural networks. And indeed, DRUM also had a major training component, and we had, in 3 specific projects, been able to reduce transmission and distribution losses, or technical losses, as well as commercial losses, from an average of about 35% down to about 15% through technological modifications, as well as good management practices. So there was a lot of opportunity in doing that. We have another program, which is called the JEP program, Greenhouse Emission Reduction Program, where we worked with a major utility in India and reduced their energy consumption in their utilities and the generation, improved the heat rate of their power plants through a number of technological practices and reduced it by 10-15%. So we have had experience on the supply side, and many of these projects have really now been taken up at a national scale by the government of India. But the project which, to my mind, actually exemplifies what I would think as taking risks as well as gaining a lot more than one would normally imagine is the Venexa project, or the Water Energy Nexus project. You see, when one looks at power supply to rural areas, typically what one encountered were significant losses along the lines, because you had long, low tension lines winding its way from the center of a village to a pump in the middle of an agricultural field. Normally, you use high HT to LT ratio of 1:2. That is, for every 1 meter of high tension, you have 2 meters of low tension. But in many cases, that was not followed, and you had a HT by LT ratio of 1:8 or 1:9. It means that the voltage of the lines are very low. There were a lot of losses, energy losses along the line. And more importantly, the end-use equipment, in this case, a pump or a motor, used to burn out because of the low voltages. And the farmers had to contend with poor reliability and so on and so forth. And there were other associated problems. I call it a vicious cycle happening because of the reasons I mentioned. And to compound it, the farmer puts up a very large pump set, much larger than he requires. If they require 3 horsepower, they put up something like 5 or 10 horsepower. And then they pump water indiscriminately, because power is not available all the time. It's available only for a few hours of the day. And when it's available, they have their pumps on. And then they use up the groundwater, and the groundwater levels keep falling. So it's kind of has repercussions all across the energy water nexus scenario. And for the utility, it is very important that they saved energy, because every unit of energy that they delivered to rural India, it was a loss for them, because they didn't get cost recovery tariffs. And they had to supply the power, because that was a socio-economic need. For the farmer, it was, quality of power, reliability, and the fact that they needed power. They got power only at very odd times and needed reliable power. So we said, why not put together a consortia of the utility, the farming community, and service providers, and work out an incentive process wherein all three come together and have a win-win project where each one gains. And through that process, we were able to identify water energy service companies who came in, made the investments required to improve the efficiency of power supply in rural India, in that particular project, improve the pump set efficiency, introduce energy, water conservation measures, and so on and so forth. And that resulted in significant energy savings, which the water energy service company was able to share in with the utility. And the utility was able to sell the saved energy to higher tariff paying industrial consumers who would be willing to pay a higher tariff compared to what the farmers were paying. And of course, the farmer gained because the groundwater levels improved, the quality of power was much better. They did not have to kind of worry about the burnouts of the pumps and so on. So it was a win-win situation all around. But here's where the benefit has, if you take a bit of a risk and you identify opportunities of this kind. So I hope that answers your question as to.
It does. It does. Let's take it to the higher level then. So for change, the sector needs motivation. In your experience, what or who can motivate the field of energy efficiency in the energy sector? So what works what will make the most difference?
Well, that's an interesting question. But just to complete the last point, there was also motivation of a different kind from the powers that be, because by improving efficiency in rural power supply, you reduced the losses and you reduced the subsidy which governments are paying to the distribution utilities to cover those losses. And now those subsidies come out from the exchequer, and to the extent that you can save money for the exchequer, much of the money can now be used for the health sector and the education sector, rather than propping up the losing proposition of the power sector. So, there's a motivation there at a much higher level. But when you come down to the level of the consumer, you must understand the nature of energy efficiency. Energy efficiency is a very decentralized subject. It depends on the actions taken by an industrial owner, by a housewife at home, by a transport operator, by an end user, really, by people like you and me, and what decisions we take. Whereas energy supply is a very centralized decision. Actually, as a matter of fact, if you have to put up a 1,000 megawatt power plant, you just need 4 kinds of people to come together, or 4 institutions to come together. You have the fuel company, you have the utility, you have the central and the state governments as far as India is concerned, and you have the consumer. They come together and they can put up a power plant. After going through, the environmental impact assessments and so on and so forth, which is statutory anyway, but a decision can be made by these 4 or 5 entities. But if you have to save 1,000 megawatts from the grid, you'll have to deal with hundreds of thousands of people, probably 1 million or 2 people in a city or in any service territory. And that's a lot of people who have to be motivated to participate. Now, this motivation, as far as individuals are concerned, to my mind, does not happen by building awareness. See, for a long time in India, and I've described that in some detail in the book, there was a lot of emphasis on building awareness. And even to this day, oftentimes when you talk about efficiency, you say you're going to build awareness. And I agree, awareness building does contribute to energy savings, but there's enough evidence to show that awareness building in and by itself does not lead to energy savings directly. There may be some, but not as much as what people think. So what do you need to do beyond just awareness building? You need to have evidence that a measure works, and that evidence must be shared with people. And that by itself is not enough. You need social intermediation so that peer pressure and peer groups are formed, which can then motivate people to save. Now, let me end by giving you a quick example. There was a utility bordering Delhi. It was a private utility, and this was, I think, in early 2000, which was supplying power both to industry as well as to the rural areas. And they were very concerned, and also to commercial areas. But they were very concerned that the power that they were supplying to rural areas was being wasted for the reason I mentioned earlier. And they were wondering how they can involve the farmer to participate, the rural person to participate and save on power. We, at that time, actually ran into a street play group, a group in Calcutta, which designs and delivers street dramas and street plays for rural audiences. But they were working on issues such as AIDS, the disease AIDS, awareness building, and other social ills, and trying to educate people against these social ills, which are common in rural areas. And I told them about energy and water efficiency, whether they would be interested in designing a play which would actually reach home the message of energy and water efficiency to these rural folks. They were intrigued, they were excited, they put together a play, and they staged that play in several villages of that utility service territory. And, we sort of forgot about it until a year later when we had an evaluation. We found that indeed, in the villages where they had the play, the savings in energy was significant. There were savings on account of the technical measures that the utility had taken. The utility did not sit back. They had taken measures such as high voltage distribution systems and transformer efficiency improvements and motor efficiency improvements and all of that technical stuff. But that savings was kind of dwarfed by the savings which was achieved on account of farmer actions on water management and water conservation and so on and so forth. And that really was because of the social intermediation, working with NGOs and getting the message across. And that was an eye-opener. And I've described that in some detail as an anecdote in one of the chapters.
Thank you. I have another question in my list, but if it's okay with you, Padu, we'll switch over to some of the participants' questions. All right, I'll read the first one I see in the chat. In many countries, electricity is highly subsidized. As a result, the tariff do not reflect actual cost of electricity. You just finished talking about this. As a result, individual industry may not be interested in energy efficiency due to less cost of energy. Again, in many industries, the cost of electricity or energy may be 6 to 8% of total operating cost. This discourages them to go for energy efficiency, saying I should concentrate more on my 92% other operating cost savings. A good example of power generation energy efficiency by combined cycle power plant utilizing the heat of power plants cogeneration. Do you want to talk a little bit more on this?
Yes. As far as Indian industry is concerned, they do definitely pay the highest tariffs in the world. Although there may be some subsidized sections of Indian industry which may not be paying cost-effective tariffs, but more often than not, Indian industry pays more. But let's assume a case, not necessarily in India, maybe in another country, that the tariffs are low. Why should the industry go in for efficiency measures? Because there's no incentive. But efficiency has a number of co-benefits, and we need to recognize that. And those co-benefits are coming to the fore these days. One of the co-benefits of efficiency is quality and quality of the product. There is a definite connection between improvement of efficiency in the shop floor and the quality of the product that you manufacture, particularly in industrial processes like furnaces and so on and so forth. There is a connection between efficiency improvements in improving indoor air quality in buildings and the productivity of people working in those buildings in terms of their health, productivity, and so on and so forth. And one must look at these co-benefits and see whether the efficiency measure not just only saves energy, but also makes kind of difference in quality of life and quality of product. So this is an important point, which I think is now gaining more and more attention. Earlier, efficiency was seen under the narrow prism of energy savings, but today efficiency has to be broadened to look at other important outcomes. The second question I didn't get on cogeneration and combined cycle. Yes, absolutely. Combined cycle systems definitely improve efficiency, and they need to be encouraged, especially in countries which use a lot of gas for power generation, such as, for instance, Bangladesh and countries of that kind. Yeah.
Okay, thank you. This one, how do you see the challenge of meeting the stiff net carbon neutrality goals? Any plans are underway for developing some energy carbon standards for the industry?
Interesting question. It's all work in process. The trajectory of meeting 1.5 degrees centigrade target by the G20 countries is going to be discussed later this month I think in Rome, and then later at COP26. It's a very, very significant discussions going on as to targets and so on and so forth. The world is going through a transition in its energy resource, no doubt about it. And what we need to kind of ensure two things. One is that this transition is done in a manner which has the least impact on the social fabric of the place, because you need to have a just transition. If I may, I think whether it's industry or whether it's utilities, especially in large countries like India, which use coal, as well as in other countries like South Africa or Indonesia, talking about the developing countries. Coal use, we might need to transit away from coal use, but that cannot happen overnight. And how do you go about doing that in a justifiable manner, in a just manner? So I think that's an important consideration. The issue of coal use is important, and let me just leave you with a statistic. Since the pre-industrial era to today, the world has heated up by 1 degree centigrade, and almost a third of it is on account of emissions of greenhouse gas emissions from coal combustion in power plants. Taking the issue of India in particular, there are something like 200,000 megawatts or 200 gigawatts of thermal generation. Almost 90% or 180 gigawatts is coal, and that is almost 70% of the total generation in the country of about 340 gigawatts. 50 gigawatts are power plants which can be retired or decommissioned. But we need to go beyond just decommissioning. We need to, as an industry, also look at repurposing these power plants to generate renewables for grid stability and so on and so forth. And when you shut down a power plant, it's people lose their jobs. Shut down a mine, people lose their jobs. There are a lot of social dislocations that take place. So it's very important that alternate jobs are created and the social fabric is maintained. And it's a very complex issue, but it's an important issue because as we see this energy transition taking place, we have to ensure that this transition is done with the least amount of dislocation.
Thank you, Padu. Still in that same vein, how can civil societies play a complementary role in further nations' intentions to get to net zero?
Well, civil society, I think, plays a key role. The question of consultation. The three issues I see in net zero. The first is stakeholder consultation. And this needs to be intensive. It needs to be along with the most neglected part of civil society. So I think that's very, very important. Stakeholders who are not normally part of the dialogue has to be part of the dialogue. The second point where civil society can play a role is that the closure of a power plant or a mine can have a disastrous effect on an economy. And it's important to act early to look at economic alternatives of diversification. So I think that's very, very important. Civil society can play a big role on what I would call its place-based development strategies, which actually means that you look at an area which is undergoing the transition and see whether in that area one can diversify into other businesses and other opportunities. And here civil society again has to play a role by coming forward with alternatives which the government can then work with. So these are some of the examples right off the top of my head I can talk about. But the civil society is a key stakeholder in this process.
Okay, thank you. I think we can squeeze in one more question. You talked about innovation in your book as well as now. What do you see as few of the transformative energy efficiency technologies becoming commercially available in the next decade?
Interesting question. There's never going to be an end to efficiency technologies because it's a function of the time and the place and the cost of energy. And you would have more and more efficient technologies replacing the others. But if you recall, when I mentioned earlier that there are 4 quadrants for efficiency, the first is housekeeping measures, second is must-dos, third is integrative energy design, and the fourth is the transformative technologies. I think circular economy is going to play a huge role in delivering efficiency. And it'll be on the backs of nanotechnology and digital transformation, which is possible. But I would think that circular economy rather would be a very, very important aspect of any efficiency, because it kind of pulls together individual technologies in the context of a matrix of development where one entity is codependent on another entity. The output of one becomes an input to the other, and therefore one can save resources in the process. So I think that's very important.
Circular economy is a hot topic these days. All right, let's squeeze in one more before we reach the hour mark. You talked about innovation, but this is almost piggybacking on the last one. You talked about innovation. What are the few innovative technologies you foresee that would have transformative impact in the next decade? Gives you an opportunity to elaborate on the previous question.
Well, yes. Taking the previous question forward, I think there's going to be a great deal of innovation possible in the area of waste heat management, innovation possible in the area of digital technology, as I mentioned. But, we should get away from the habit of identifying winners and losers here. I would rather look at innovations possible through different arrangements where different entities could come together to deliver a product from the laboratory into the marketplace. How do you innovate to get a basic technology under research through the stages of development and then pushed into the marketplace through commercial arrangements? It is that kind of an innovation, I think, that's important, and for which one would need really, and this is something which has been talked about before, and I've discussed it in great detail in my book on one of the chapters on Hobson's choices, where one looks at institutional arrangements between the world of finance, the world of technology, and the world of end users, and getting them all together in order to kind of develop a product from the research stage to the final delivery at the market stage. And it's that kind of innovation which will create the ecosystem necessary to bring in new products and processes into the marketplace. And that's what my goal has been in the book, is not really to identify specific technologies or to come out with a checklist, but really to look at the process rather than the goal of developing technology.
Well, I think that's about the perfect ending.
Your question, but I kind of explained the innovation comes in the process rather than in the product.
Very good, very good. So on behalf of U.S. Energy Association, I want to thank you, Padu, for taking this time. Padu's currently located in the U.S. right now, so we got him up nice and early for today. So we really appreciate your time. I encourage anyone who hasn't checked out the book, you can get it on Amazon, and it's available in India, it's available in the US. I imagine it's available in much of the rest of the world as an ebook or as hardback. But we really appreciate you taking the time. This book has shared so many lessons that I think, yes, they're from the India's history, but they can be shared across the world. So I encourage anyone, no matter where you're from, to take a look at it. It's filled with some great anecdotes and some really good lessons. So thank you, Padu. We really appreciate it. And we look forward to the next opportunity to chat with you.
Thank you, Sana. Thank you very much. And thank the viewers, and good day to all of you.
All right. Good day, everyone. Thank you, and see you next time.